All right, thanks everybody for coming. Jacob pulls a big crowd, so we appreciate him giving us his time and for you all coming to learn a lot about what they're doing. Before I intro Jacob, I wanted to bring Chase up to the stage. I don't know where he is. There he is. He's our sponsor. If everyone give him a big round of applause. Brought us the pizza. We always appreciate that. He has founded a company called Piton Ventures, and I'll let him introduce it more, but they're doing some really interesting stuff, especially with AI, so very applicable to what we're about to talk about.
Thanks, Tyler. All right, thank you guys. I will keep this short because we are all excited to hear Jacob talk today. My name's Chase Huntsinger. I'm part of Python Ventures. Just a quick intro on us. Basically, we are a finance and strategy advisory for teams that are building with AI. So whether you are an AI startup in the early stages or a larger enterprise that's building LLMs into existing tech solutions or your operations, what we do is help engineering and product teams kind of navigate that process to make sure that you're building solutions that are scalable and have a business model that will last. So prior to launching Python Ventures, I worked with Microsoft and GitHub, helping launch and scale GitHub Copilot and Microsoft Copilot Studio and other agents. And we're basically doing the same thing now. So pretty regularly, the types of conversations that we have, involve partnering with engineering and product teams to talk about product architecture and feature flows. We get really deep into like tokenization rates, input, output, latency requirements, geolocation, basically everything that would influence the cost to serve an AI product. And then we help translate that into a business model, pricing and packaging that makes sure that it can scale. So I love this space. I love talking about LLMs and AI. So if you ever just want to send over an article or chat about where the industry's going, feel free to reach out. Other than that, thank you guys.
Thanks again. Definitely check them out. We've got Jacob as our speaker. He's probably a man that doesn't need an introduction here in Utah. He does a lot in the community. I've seen some of his talks, and he's a great speaker. I think Patterns are doing some of the coolest things with AI, data engineering in general right now. Really hard problems in the e-commerce space that you need to get right, and AI can't hallucinate, fake product descriptions or other things. So it's a really hard problem that they've done a lot of work on. So I'm excited for him to teach us what he's learned and what Patterns doing. And if you can give him a round of applause, we'll get going.
Thank you, Tyler. That's awesome. And Chase, phenomenal. Let's dive in. So today's talk is Principles of Applied Intelligence for Organizations. That's our focus today, is with organizations. Rather than, say, your personal use, which might be amazing, and I have lots of opinions about that, as some of you who I know here know about. But today, first, we got to start with a disclaimer that Pattern disavows everything I'm about to share with you. Okay? And with that being said, we're ready to go. Should be a lot of fun. So there is, if you want to, should dive into this. There's a great article, if you want to get a more polished professional version and a different opinion of what I'm talking about today. I put together this presentation over kind of the last 4 months that I've given portions of this presentation today. But then I saw this article very recently covering about 80% of what I'm covering. It's like, oh no, someone else is on to me. So I highly recommend this article from the LangGraph team on how to think about agent frameworks, which informs a lot of what I'm covering today, maybe about 70%. There's some unique, there's a lot of really great unique perspectives that they have, on the LangGraph team, that's been really interesting. Highly recommend their blog if you're looking within the space. How do we tackle this problem as an organization? Lots of great information there, but there's also a lot of frameworks that they dive a little bit deep, and I want to zoom out just a bit more than they do so you understand where the puzzle pieces should be dropping. All right. So one thing that's been helpful for our team, for specifically my AI team, is to have our mission statement, essentially, our purpose statement. And our purpose statement is to build the infrastructure, tools, processes, training, and culture to implement, scale, and maintain value-creating AI across Pattern. And that's an important series of steps. That doesn't mean my team is actually going to build all of the solutions for all of the teams. It's not like there's an AI engineer that we have on our team that's going to go build all of the AI engineer solutions. Rather, we're trying to turn our software engineers into AI engineers and support them and give them the tools necessary so that we can implement, scale, and maintain value creating AI across Pattern. So with that as a fundamental framework, okay, I'm thinking of how to enable everyone else in order to create value. So today's objective is to develop an understanding that I have for you, develop an understanding of the wider vision of building AI into our products and processes. Then you might be wondering what that actually means. What I want to do is to go over a foundation. This isn't a mastery course. Second is the wider vision and processes. Frameworks, not tech. That's very important for us, is that we can explain and solve problems without specifying any individual piece of technology. If you can't abstract away and solve the problem abstractly, throwing the technology in and assuming that they can solve it, it doesn't work out very well. And finally, it's products and processes. This is very specific for us. And what's helped crystallize for us working with AI, working in AI across our teams, is this framework. So this took way too long for us to develop this framework. You're like, it's a 2x2 matrix. Like, I know. It took like 30 hours of work to create this 2x2 matrix to clarify things within Pattern. So there's different types of users. So there's end users or individuals, and then there's serving organizations. And then there's internal, say within Pattern, and then there's external, outside of Pattern. So if we have an end user and it's internal, they're looking for a co-pilot to help them to work with them with their job. Usually it's an external provider. So GitHub Copilot is an example of this. It's a thing that programmers used to help do their jobs. You're trying to find the best solutions, generally evaluating external options, but not always. Then there's where the end user is external. This is a product. We are trying to build a product with AI components and deliver it to our customers in a way that adds value. Then there's internal within our organization. That's when we're trying to map out our processes and workflows and have AI enable everything that Pattern does. Sometimes that's going to be off the shelf, that some product that somebody has. Other times we have to custom build it and give people the tools and technology so that we can automate and streamline a lot. And that's a lot of what we do at Pattern, because we are trying to make the service components of the e-commerce business as painless as possible. Finally, there's external and organization, which is more like a platform, and you're trying to integrate across different organizations, like MCP is really big in this space. So what I want to focus on today are these two in green, which is customer products and processes and workflows. And the reason why I want to focus on them is because A, they have a lot in common, and B, the principles that we apply in these areas aren't context specific for the most part. So when we're talking about co-pilots, it's very specific to the job that they're doing. So if they're doing software engineering, that's very different than if they're doing like AI within Photoshop. And if you're trying to like extrapolate principles from it, it's basically like, does it work and how good is it, right? It's a lot more specific. So when we're talking customer products and processes workflows, that's what I want to focus on today. So what makes for a trustworthy AI? Oh, that is like a really controversial question. One approach that we have is that if we nuke trust at any point, it becomes extremely hard to get it back. That trust actually trumps effectiveness. So you can go to our users, whether it's internal for processes or external for product, but if you have not established trust, it doesn't matter how effective it is because you don't get adoption without the trust. So for us, trust, we generally break it down in this framework. We've been iterating on this internally at Pattern. One is transparency. You know how it arrived at the answer. So AI, generative AI, is kind of a black box, but there's elements of it that you can make transparent. One is accurate. It gets the answer right. A lot of people think, oh, it's trustworthy if it's accurate. Like, no, that's part of it. That's not everything. Also, is it calibrated? This is really, really hard for generative AI. This is the answer. Are you sure? Yeah? No, and the inherent architecture underneath LLMs, they're probabilistic at the token level. They're not very good at being probabilistic at the certainty level. And there's been a lot of work to try and improve that, but getting proper calibration is difficult to get right. But when you get it right, when you tell when you tell someone, I'm sure you've gone to someone for advice, and they tell you, I'm not very certain, very low level of accuracy, but then they give you advice, and it's super helpful because it's very well calibrated. They're not saying you should for sure take action A. They're telling you, no, like I have a lot of uncertainty, but here's what I think it's super valuable. So when people say, oh, it's not very accurate, therefore it's not useful, it's like, wait. Is it calibrated? Is it transparent? Finally is alignment. We'll just kind of gloss over this one, but it aligns with my values, or at least you know its values. So if you were to ask, let's say a certain model, not to be named, specific questions about things happening in the world, it might be biased toward one specific country, right? And if you know that going in, it helps a little bit, but you want to know if the generative AI underneath the hood is actually aligned with what you're trying to accomplish, more than just the transparency, but along the objectives. So why do most AI projects fail? Why do we lose trust? It's generally because when we scale into production, we lose kind of that Taka mindset, that transparency, accuracy, alignment, and calibration. We were super confident on something, and then it blew up in their faces. And it's like, oh, but it worked 95% of the time. It's like, yeah, but that 1 in 20 blew up the business. Ugh, that's no good. So how do we improve as we are building? What I want to walk through is we have two things available for us. We can either improve our success rate, or we can fail a lot faster. And mostly what I'll be talking about is improving the success rate rather than failing faster. But I do want to talk about failing fast because I believe that failing fast in AI is a competitive edge. If your team can fail faster than everybody else, you actually are in front of the competition if you can develop this as a core competency. That doesn't mean you just instantly fail every project, right? That would be bad. But if you can get to failure faster than others within your industry, within your space, you will be in front of the competition. And this is just quick aside of what this looks like for us when we talk about failing fast, okay? Generally, we talk about effectiveness and efficiency in AI. Effectiveness, did it deliver the value? Was it accurate? Was it calibrated? Was it effective, okay? Efficiency is how much cost and humans got to be involved. If you focus exclusively on effectiveness and nothing else, you can generally fail fast because that's usually where projects fail. You scale them up into production and they're not as effective as people thought. Ugh. A lot of the time, this can also be performed by non-technical users. They can sit down and literally just create like a SQL data pipeline, copy and paste it into whatever, LLM service or Gen AI service that you have, look at the results and just repeat it 100 times. We built a custom app internal within Pattern to help people do this extremely efficiently, like 500, like upload this CSV in this exact format, here's all the outputs. And it's, they have all the things that you can mess around with, which model and the size and a bunch of stuff like that. And like, is it any good? Like, we don't even need to start building. A non-technical person can establish effectiveness right out the gate, and then we can talk about efficiency. If you invert those, you're going to fail slow, and it's going to be bad. So, quick aside on failing fast, highly recommend, which we talked about. So, let's focus on improving the success rate. So, this is what I've been talking about, of kind of these principles of applied intelligence, of improving success rates, specifically within customer products and internal processes. And I have a book upcoming on this topic. Should be fun. Comes out like end of the year, early next year. But this is the gist of it. Geometrical objects, easy to remember, is memorable. But we have that. This is your AI universe right here. So you start with the output, where you're creating feasible, scalable, and impactful AI workflows and agents. You're off to the races. Second is that you have your data. You want to have potent data that can actually drive the outcomes that you want. You want models that can consistently select and optimize the best approach. Finally, observability. You maintain trust through observability, because if you don't know how well it performs, your users will tell you, and it will be bad. And finally, the enablement layer, which a lot of what my teams work on, is minimizing friction to implement and maintain this. In order to scale this, these are all of the components that we need This is our approach. This is how we think about the problem, is get all 5 of these ducks in a row. And by the way, these are in order of importance, 1, 2, 3, 4, and 5. If it doesn't create any value on output, then there's no reason to chase data. If you don't have the data, don't make a model. If you're not doing the model, there's nothing to observe. If you don't have the observability layer, like what, there's nothing you really need to enable in order to scale this thing. And so usually we tackle problems in that order, 1, 2, 3, 4, 5. But we are building the tools to help us on each step along the way. In practice, what does this look like to become an AI superstar? Looks something like this diagram. You want to make sure that it adds value, you have the potent data, it's an effective model, maintains trust, accessible and easy to maintain. You're going through each one of those steps, and you get to the end of it, and people are like, oh, you are an AI superstar, you are amazing. And you celebrate, and great, and you don't have these issues of it didn't scale into production, oops. Right? So here we go. So today I will only be focusing on the output component. Otherwise, we'd be here for like 4 hours or something like that. I don't know how to make all of the rest of the components. There's so many intricacies in the other ones. But output is where we need to start to generate value. If you have the output portion down, you are very bright people. You'll probably figure out steps 2 through 5. You'll make it through eventually, but part 1 is usually where we're seeing the most companies struggle. So we are diving in. So the output is defined by the larger process that it belongs to. So is something valuable? I don't know, it depends how it's used. My AI process, I'm going to generate certain AI output. It hands it out and then does what with it? If you don't know what it's doing, you have no idea how to build. So what is the wider picture, okay? So this is another framework of how we think about these problems, and just, we kind of call it the 3 I's of our AI workflows, or arguably components of AI agents. And it's where you start with how does a process initiate? This is all part of a larger whole. Exactly how does it initiate, and what is required at the very beginning of the process? What do we have at the beginning? Then there's this thinking and deciding, which is like AI or AI with human or something like that. But outside of the AI component is the iterate and approve. So is it any good? Does a human approve it? How do we know that it's any good? How do we move forward? And then finally, implement. How is this going to be implemented afterward? Until you figure out like the initiate, the iterate and approve, the implement, until you've figured out those components, it doesn't really help to work through the think and decide portion, because as the other portions change, your think and decide is also going to change. So that's the wider context there. The mantra that we have around this is build like a software engineer, but think like a data scientist. And the reason for that is that data scientists are really good at failing. They failed a lot. So during the late 2010s, data science teams would be thrown stuff, like 80% of their projects would fail. They got very used to failing and establishing really strong frameworks of like, how do we fail fast? How do we evaluate feasibility? How do we do things? So data scientists have just been like suffering through this for a decade and have learned a lot. Software engineers are now grabbing generative AI and going, wee, and they're making the same mistakes that data scientists made a decade ago if you don't learn from the mistakes that the data scientists are doing, or that had done. And so you still need to build like a software engineer. This needs to be scalable in production at a level that serves all of your customers, that is performant, the uptime is amazing. You're thinking like a software engineer as well. You're building like a software engineer, but you're gonna need to think like a data scientist because your surface area of what can go wrong is enormous. And you need to be aware of that. So when we go through these, the things to think through just really quickly: initiate. How is this workflow registered? What triggers it? What are the required inputs? Thinking through all of that before you're building is very important. Will those inputs be available? These are things that data scientists think about. When the moment of production hits, what data is available? Oh, that data's on a 5-day delay. Well, then when I train my model in data science, I need to pretend all my data has a 5-day delay. Like, these are the kind of things that data scientists naturally think about. And in software engineering, when you're building in generative AI, if you're not thinking that way, it's going to catch you unaware. Finally is think and decide. We'll talk a little bit more about that later, but it's human and or AI models transforming the inputs into outputs. For iterate and approve, how do you know if the quality is good enough? And should we repeat the think and decide step? If this fails, do we escalate? How do we escalate? What does that larger vision look like? And finally, an implement. Oh, I want to go on this tangent. That's right. You guys have heard of human in the loop, I assume. Tons of nods, human in the loop. Where human is in the loop, the AI isn't just going off and doing stuff, but a human is stepping in. And it's so cool, and these AI engineers came up with this term, and it's like human in the loop. Isn't this amazing? And there's like human on the loop now. There's all these terms. It's really cool. And it's like, wow, who came up with this framework? And so when I was looking at this, I was thinking because like I did like risk analysis like 20 years ago, starting my career. Like this is 1992 COSO framework. Like this is, human in the loop is not new. And what it is you have the output quality on your x-axis, you have your input on the y-axis, and when your quality is low but the impact is high, you want what's called a preventive control, also known as human in the loop, where a system cannot move forward until a human steps in. If the model quality is high, but like the impact, risk is kind of low, do a detective control. What is that? You just wave it through, you generate a report at the end and say, here's the 500 things that I did for you today. And someone can look at them after the fact and say, great. Preventive controls, detective controls. It's funny how in every discipline, we just reinvent what the other disciplines have done. But the reason why I like calling this out specifically is because human in the loop, people think, oh, I need human in the loop, but when do you need it? And just having that really convenient COSO framework from like 1992 at least, of like impact and quality, this like risk assessment, and drawing this line of like where do I move it from human in the loop to not human in the loop, making that explicit with a product manager can really help move your product along. Otherwise it's like, do we need it? Do we not? At what level? Like let's make it explicit. Let's figure it out. So finally, implement all the stuff you guys know in the software engineering world, but it's the larger vision. So here's a term that we hear a lot. It's AI first process design. And there are a million definitions. So I'm going to give you 1,000,001 for how the million and first definition of how we think about AI first processes. And AI first design is taking this process and designing your processes and products in this same format of this initiate, think and decide, iterate and approve, and implement. So you start, if you structure a process or a product that's explicitly like this, you have a nice smooth flow. So what you do, you have a human that's thinking, and then maybe you switch it to a copilot scenario where it's human plus AI, and then maybe eventually you move it to an AI scenario. If you can structure a process where you don't have to refactor the entire process by swapping it out from AI, human plus AI to human, and jump between those levels, your life gets a lot easier for a lot of reasons. One is, we call this like human AI agnosticism, a tenet of agnosticism. We're gonna design this process, and in the end, maybe a human does it, maybe an AI does it, maybe it's both. We don't care until we get to that juncture. And if the full AI automation approach, we go in that direction and then it fails, guess what you can do? You can just tick it down a notch and do human plus AI and you have a win instead of a loss. And racking up half wins is a lot better than 0 wins, right? Your AI projects don't need to have true false Booleans, was it successful or was it not, if you can have gradations and you can have a safety net there. Well, that's only possible if you've designed this so that the human and AI components can become interchangeable. Thinking through that. So it's that Lego bricks mentality, and you're minimizing the friction to swap in AI in that point. So if it's super hard, it's a major refactor, it's awful. If it's pretty simple and straightforward, and you just click out one module for another, you're off to the races. And that's how you can create what's called salvage value of your products. Because it's like you cross 98% of the ocean, and you're like, yay, that's an A. Like, no, that's your ship sunk, and you died. That's not an A, that's bad. But if you create salvage value out of your products, out of your projects, then you get that far and say, okay, the ship sunk, but at least we recovered a lot of its cargo, right? And all of this requires a digital foundation. So those of you who are old, like in my end of the spectrum, you probably remember Digital Foundation. This was really big in the 2010s, right? Like you have a digital foundation. Basically, is there a digital foundation? Is everything being captured digitally along your process? That's number one. Is it being captured? And then number two, is it talking to each other and is it integrated? A thing that we see, like what really impedes AI first design, is that what people do is that they walk forward and say, we're going to implement AI. They do not have a digital foundation, either because it's not like in digital form yet, or it's not integrated. And then they have this huge, then they like try to force the project and generate tons of tech debt. It's super janky, doesn't scale into production. Like, it's the same thing that's been talked about for like 20 years, guys. It's just the AI first, the digital foundation is a prerequisite. Finally, we start getting into more of the AI stuff. So this should be building on our previous principle of like these 3 I's of these AI workflows. You can then start wrapping these things. How do I make it modular? How do I standardize it? I need to register it somewhere. I need to wrap it in some way. There's required inputs, your expected payload. You need docs. There's optional evaluations. I would remove the optional. You need evals and you need observability. And so there's these platforms that are out now that will help you do this. They're not super complicated. You could also kind of build it yourself or grab something off the shelf. There's open source options. So this is what it's turning into. But I love the idea of wrapping all of these in these initiate, these kind of 3 I's around your AI runs. Because what that turns into, if you can get the individual piece right of the single AI workflow, then you can start chaining and stacking and creating more complex AI workflows that people make it look like they're doing on social media that are probably not scaling into production. But you can get closer to those ideals of those mind-blowing proofs of concept that somehow don't become products a lot of the time. You can start building that in that direction. If the individual building blocks are built correctly, you can start stacking them so they can run in parallel, then come together, and then start chaining them where one goes after another. Nice. So let's go into another really fun, non-controversial topic, that 2025 is the year of the AI agent bubble. So if your organization does not have value-added, scalable AI agents going on right now, no one else does either. You're fine. No FOMO. Don't worry about it. This doesn't mean don't do AI, but there's a lot of FOMO on AI agents. There's a proper time and a place. So I wanted to address this really quickly with another framework that took us way too long to kind of come up with. There's others in the space that are kind of emerging with this idea and standard. So AI can go and do and take an action and resolve something for you, or AI can orchestrate with tools available, AI workflows available, and orchestrate the solution, okay? So traditional software engineering would be like a non-AI action and a non-AI orchestration. You fire up Airflow or whatever, like it's deterministic, it's following this path. You take these steps and then you're done, right? That's traditional software engineering. Then there is orchestration where you have AI with like non-AI execution. So like Alexa and these other, like, I don't want to say the words because I might summon the demons if I but those are examples of limited agents, right? And so you ask it specific questions, and there's kind of an AI layer that's trying to classify and understand your problem, and then it has a million tools underneath, more like a few hundred tools. It has a few hundred tools underneath where it's going to try and take certain actions, like find out the weather, look at your calendar, and do some deterministic action. So the thing under the hood is not AI. It's not like, write this email for me and send it, right? It's taking deterministic actions. And we've had those for years. We've had these limited agents for years. Agents are like not this new concept because like they've been on our phones and they've been of limited use. You know, they're kind of okay. Finally, you have where an action is AI, but it's purely deterministic in the orchestration. Like when we want to solve this problem, these are the steps that we take. This is exactly what the AI does. It takes this input, looks at it, generates an output. So what we just saw, even with the chaining and stacking, that looks really complicated. That's all AI workflows. You don't go to the very beginning, feed it into a generative AI and say, figure it out. Good luck. Here's a bunch of tools. But that is what agents are. Agents is when you hand a bunch of tools to an AI and say, good luck. Go for it. And as you can imagine, this can be kind of challenging. So it's not we'll skip that for a second. So it's not it's not that agents are like a bad idea or a bad concept, and it's not that they're not going to eventually add value. It's that people will chase agents before they create AI workflows, which is probably like the biggest mistake ever. If you don't have a functioning AI workflow, and then you say orchestrate on top of something that's not working, what do you think is going to happen? Right. Okay. So where's the bottleneck for value? Where's the value today on what you can work on walking away, like back at your companies? I want to go through a couple concepts. I told you I'd make this a little bit spicy, Elmo fire meme. But how are we going to build these orchestrations? So some people are saying we're going to do low, no code as the future of deployments, and we're also going to give it non-deterministic guidance where we just say figure it out. And we're going to combine these two together and usher in a new age of utopia. As you can probably imagine, I'm not in that camp. First, on low, no code is the future of high impact deployments. Not to call anyone out, this has been tried over and over. Not that there's anything wrong with like low code or no code, but pushing them into production and having it like someone moved an arrow and you broke prod, it's not so good. You want stable, scalable systems that people trust, because as soon as you nuke trust, it's all over anyway. There's a graveyard of these low no-code solutions. That doesn't mean that a visualization is bad or anything like that, but like you can't rely on like a no-code solution to push it into prod. So this is like quotes that I'm sure you've heard lots of times. For those who've been around, yeah, no code has not won the day. But then you have these different orchestration options, and some of them are like build this with no code and drag and drop and things like that you see. Some of them are just visualizations, and that's fine. But just something to keep in mind, if people are messing around with arrows and it's breaking prod, you probably need to fundamentally change what you're doing. So with the non-deterministic guidance perspective is that we were so preoccupied if we could enter into this world of non-deterministic agents to do things, yeah, that probably wasn't the greatest idea. So people look at Gen AI as like, yes, I needed this as an orchestrator. That's exactly what I needed. It's like, that is not the first thing that came to my mind, but evidently it caught fire, it like went viral. So the success of an AI orchestrator is determined by the product of its parts. So if you multiply 0.9 times 0.9 times 0.9 times 0.9, over and over and over, it is inevitably going to fail. This is the inherent challenge of AI agents. Now, if the AI agent is just working as co-pilot in tandem with a human, it's not that big of a deal. Like, come up with some good, here's a bunch of tools that it has, what are some different marketing ideas, and it feeds them to you. It's a low failure scenario, you've got human in the loop, it's not gonna go off and do anything crazy, right? So I'm not saying like there's no uses for agents, or even today. There definitely are, but you have to have the human in the loop because of this product of its parts conundrum. And this was a quote that I saw recently, which is, our own tool calling benchmarks show that current models fail to call the right tool about half of the time. And if you're calling multiple times, this is no good. Like, this is not only the product of its parts, it's a low product as well. It's a low number. So then people ask, like, what's my orchestrator? Partly, like, jokingly, I'm like, I don't care. I do care. There's some good options out there for orchestrators. But the first question you need to ask is, how are you going to be doing orchestration? And there are a ton of solutions out there. LangGraph was one of them that I showed, that the people are moving in that space. Nathan, we've seen people use, what is that called? Netflix Conductor, and there's a few others out there that people are using to push to track and push these orchestrations through. Lots of great options out there, but like dumping it over to the agent and like this is the future and we're not going to have any sort of orchestration layer, like, please don't do that. Not yet, at least. So where's the money? And the money right now is in AI workflows. If you can build appropriately that scales into production, that solves a key pain point for either an internal process or an external customer, you plug it in, it's amazing, it's magic. You're starting to see this in products today. You're starting to see really functional AI workflows under the hood of products that you're using, and you're like, this actually is pretty good. And I'm really happy with it. You're seeing people find this, but it's within the AI workflow space. So I wanted to end today with an example. So Pattern does e-commerce stuff, so I'm really familiar with e-commerce stuff because that's all I do and breathe and work on all day. So let's suppose there's a listing with some product that's on Amazon, okay? Some phenomenal product, vitamin D, super healthy, take your vitamins, I wanna do this. But what happens is there's something that someone introduced on the listing that is like no good. Like you introduce it on the listing and then it makes the listing go down because Amazon doesn't like the claims that you're making. And this is what I wanted to walk through is just a nice little diagram, very simplified form of an example of an AI workflow. So let's say your listing goes down and Amazon's like, because of listing issue 437, your products can no longer be purchased, and that is bad. And so for a solution provider like Pattern, our goal is to minimize the number of minutes that the listing is down. We need to fix the issue and get it back up in the fewest number of minutes. That's why brands pay us money. They didn't want to like kind of go figure it out with, with their small e-commerce team over 3-4 weeks. They want us to solve it instantaneously. So you can design a process. You have listing issue 437. Okay, you get this from your services API, it's passing it through. We need to resolve this, here's our task. You have a classification problem, is this type A or type B? Type A, you said that it would be great for East Asians, like that's not allowed. Or maybe you said it cures cancer or like improves cancer survival rates or something like that. That's also not allowed. So the blue square, the blue rectangle you see there is the resolution process, is the thinking and deciding component, where it's passing all of that information in and saying, based off of what I have here, all of the information about the product, the brand voice guidelines, and all of these other pieces and components of things that you need to know, take this listing, remove the offending portion, replace it with high quality content, and pass it on its way. And we want that to happen basically instantly to get that back up. So what happens is that we generate proposed changes. That goes into the database. It then passes on into a step. Is this a detective control or is it a preventive control? Depends on the scenario. If we just change something and this product sells like 10,000 units a day and is selling like millions and millions of dollars, maybe you want a human and you have a team like 24 hours a day that's catching like the highest profile, highest impact items to give it a second look. You make that decision based off of the model quality, but also like what is the impact, what's going to happen. You have metadata tags associated with that, like where did this come from, here is the product, how do I decide that? If it's detective, you can just wave it through, syndicate the changes, send it through the network, and get it back up as quickly as possible. You need a human, pass it off to the human, they review it, send it back through, syndicate the changes, you're on your way. So very simple example. But this is an example of something that's worthwhile to us because we face this hundreds or thousands of times, and we need to resolve it as quickly as possible. And this is a core part of Pattern's offering to brands is to solve all of these individual pain points. And so for us, the focus of AI isn't, hey, wouldn't it be cool if AI could, schedule our meeting lunches or something like that? Like that's cool. But if AI is not integrated as part of your core service offering, of what differentiates you as a company and as an organization, one of your competitors probably will. And that's going to put you farther and farther behind. And so as you're starting to jump into AI, I want you to start thinking, is this being implemented to improve what differentiates us on the marketplace, what allows us to create value for our customers, for our brands, on who you're serving, okay? Nice. So, quick recap, we were just covering output today, but these are all the components of thinking about when you're building within, remember, the internal and processes, like workflows side, or in the opposite corner for external and customers. This is the paradigm that we've found to be super helpful. And we can dive in for questions. Thank you. Sorry. So quick to call out Josh James. Did I? Oh yeah. Yeah. No. That's a fair point. Yes. Yeah. No, that was a part of the offer. They do a lot of things besides that. Okay. But one of many, many companies that tried to push out one of those kind of like low no-code solutions into prod, it was one of the many products that's been pushed out there. But they've created lots of other products that are useful and valuable. I know that was I should have taken that one off. That's a sensitive subject. I asked AI, which make a list of these, and it generated them, and I'm like, well. Maybe I should have done more human in the loop on that step for my presentation given the audience. Thank you.
How do you envision or see the shift in that agentic patterning from a rules engine to autonomous decision making?
Mm-hmm.
Right? Because a lot of our customers in the retail space are very hesitant to hand over the reins on decision making to AI processes.
Yeah, I think there's a series of events that has to happen. So one is if you solve for the AI workflows and they're working amazingly well, then you can start considering, what if we use AI as an orchestrator for what's already working really well? But if you don't have the AI workflows first, it's like this prerequisite to even try. But a lot of people jump the prerequisite and just try to like moonshot it, and then it inevitably fails. And like, oh, why did this fail? Like, well, you don't have the tools and AI workflows under the hood that are super high quality and with observability and trust. Because if the individual components are working, then you're only evaluating the orchestrator, right? You're not when it's a product of its parts. And all the parts are one that you're multiplying by, except for the final one. You can evaluate the final step as the orchestrator. So that's the key point that I would keep in mind. Like it's going to be here eventually, assuming the models improve and improve and improve, and we get there. It's probably going to be there. But there's also an argument for is generative AI the best approach as an orchestrator? So people are trying to use LLMs as orchestrators. There are other forms of AI that might actually be better and actually have like reinforcement learning attached to them that might actually be superior. And I don't know, we'll see over the next 5 years. That's kind of where I'm bullish, where my eye is.
In one of your early slides, and if this is rudimentary, I apologize, but you distinguished accuracy and confidence.
Calibration, yeah.
Calibration.
Yep.
Help me understand the difference, because if we're not accurate, I mean, we are not calibrating if we're accurate. Mm-hmm. But you had those as two separate things, and I guess my mind didn't really pick up on the distinguishment.
That's really worth highlighting. So if a model tells you, I have no idea, because it doesn't have any idea, you can then go take the appropriate action. If it's like, no, like full send, I've got it, I know, and it gets it wrong over and over, that's a huge problem. And so if the model is properly calibrated with like the right level of confidence, it's ready to move forward and communicate that confidence to you, and you're ready to move forward. So with the human in the loop framework as well, if the model's like, I don't really know what I'm doing, it's a lot easier to flag that human and say like, hey, we need help to get through this. But if it's not calibrated, then it doesn't, which is different from accuracy. So if you have a model that's 95% accurate, but is 100% confident, and 1 out of every 20 blows up the company, you can never implement the model. And so that's the differentiation there. It's like you have the accuracy, but then how well does it know when it doesn't know? Okay, that's fair.
I can probably say it loud enough. That's true of any. Oh. That's true of any human too, by the way.
Yes, that is definitely true with humans, because there are people who are like, they're really, really smart, but they're 100% confident all the time. And then you're like, I just don't know if you're just confident on anything they say. You're just like, well, I don't know, because you don't know how to calibrate. Yeah, that's true of humans. It's true with AI. That's a great point.
Where would you recommend starting for a business that might not have that data foundation necessarily, but do you think using third-party tools as kind of a wrapper around all this can be just as effective, or do you have to have the data foundation and like software engineers building all this stuff?
The tools can help some, but you have to have the digital foundation, because what makes these things useful is that they work for you. Like if you're just like using ChatGPT for random stuff, like that's cool. That could help as like a co-pilot, I guess, for someone who's doing their job. And getting people comfortable within the company using AI is definitely a plus, and that helps. But if you don't have the digital foundation for your processes or for your products to actually connect all of this together and know what's going on, it's going to be pretty generic and undifferentiated. That doesn't mean don't do it. It means get people accustomed to AI while you're building out the digital foundation layer, and prioritize the elements of the digital foundation layer that will naturally turn into projects for your company. Does that kind of make sense?
Yep, thanks.
Maybe this is a little technical, but do you have any advice for companies that are considering like fine-tuning versus, maybe using an out-of-the-box model with just adding extra context to kind of substitute for that?
Oh, this is one of my favorite questions.
We get asked that by clients all
Yes.
the time, and it's hard to give that answer, so I wanted to get like your take on it.
So, because we have time, I will tell you the slightly longer story and more fun version. Is 2 years ago or so, Bloomberg, like the finance company, they were like, we're going to fine-tune a model on all these financial documents, and it's going to be amazing. And everyone's going to use our product. And like they fine-tuned their model, and then like GPT-4 came out or whatever, and then like they were worse. And so we joked about this as like the fine-tuning trap. Like you can either fine-tune a model, or you can wait 3 months and get a better model. And that's been the fine-tuning trap over and over and over and over. Now, of course, that doesn't extend perpetually into the future, short of, fast takeoff and singularity. Now, if you're in the fast takeoff singularity camp, like that's fine. But for the rest of us, at a certain point, the models for your specific use cases probably will not just be like jumping by huge steps for your use cases, and at a certain point you will need to fine tune. So that's going to, one, depend on the use case, and two, your expectations on how fast models are improving specifically for your use case. And if you want to try that out, by the way, just fire up a use case for your example, and then pass through, so, you got like the Lego pieces, use one like OpenAI model or Claude model, then use like an older one, and then an older one, and an older one, and like see what the jumps are. Like, do you think that's actually going to continue or not?
Thank you.
So it's going to be use case dependent. Sorry, that's not like some universal answer.
No, it's good. Thank you.
Nice. Any final question? We have one timid one over here, or I guess one in the corner.
So you said 2025 is a bubble still, right? We're like 5 months in, and you see all the new models, especially the Chinese ones, right? Very strong, very powerful.
Mm-hmm.
Most of the companies, they have something in there, they're using AI. First of all, why do you think it still is a bubble, and when do you think the bubble is going to be burst?
Yeah, so to be clear, the AI agent bubble is AI as orchestrator, not AI as, say, workflow or how you're applying that AI, whether it's like a copilot or a workflow. So what I'm saying is feeding into an AI and saying you have 100 tools available, just go figure it out on your own. Yeah, that's what I'm saying. Like, that's on the bubble end of the spectrum. We'll see in a couple years, like how that matures and develops. But that's where I'm more bearish. And to expand on that concept a little bit more, you guys are familiar with like the computer, like Operator and Manus, like the AIs like clicking around your screen. I think it's hilarious. And the reason why I think it's hilarious that you have an AI that's like clicking around a screen is that we will go to immense lengths to not build an API. We will go, we're going to solve, we're going to use an entire generative AI process. It's going to click around a website. It's going to do all these amazing things. All of this to just not build an API. Now, over the future, what will probably happen is that the web will become more and more API based so that your AI workflows and agents can actually interact in this wide world of the internet without like trying to click around things and solve CAPTCHAs. Nice, fantastic question. I think there's one over here.
I'm new to this space, so I'm sorry if my question is a dumb one.
Welcome. We're
Hi.
all new. Don't
Well,
worry.
So I guess I'm waiting to wake up one morning and read the story about how one AI met the other and started using it to improve itself. And I don't know if you have any experience with that or can give us some insight as to what's going to happen when they start to collaborate with each other or outright compete with one another, I mean, on that front. And I know we don't have the sentience yet, but that's probably the step that unlocks it. So I just would like to hear your perspective on that.
Yeah, so if you want a fun read, there's an essay, website, whatever, called AI 2027. Some of you may have read that one. It's popular within the space. A lot of people are talking about it in the space of what that can potentially look like. They are very bullish on acceleration, also a little bit doomsday. And they have a very interesting perspective. I'm not quite that like takeoff oriented as they are. But as far as the individual steps, maybe not the timeline, but the individual steps, that's a very interesting read. And those people have thought about this a lot more than I have. Even though I don't agree really fully with them, they've laid out a lot of the critical points. Would highly recommend AI 2027. Nice.
Okay.
Thank you so much.
Thank you, Jacob, and thank you, Chase, with Piton Ventures. Really appreciate you all coming out. We're always looking for new presenters and certainly sponsors for our Lunch and Learn, so if you have any ideas and you have sponsors in mind, please make sure you let myself or Tyler know. Also, if you're not following us on LinkedIn, be sure to follow the AI chapter on LinkedIn as well, because we always have these Lunch and Learns there as well if you're not in the portal for Silicon Slopes. But super appreciate all of you guys coming out, and thanks for your time.
Thank you, Silicon Slopes.